I am Dr. G. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, B.V. Raju Institute of Technology, Narsapur. In today's class, I am going to discuss on the concept of supernode analysis. What is the concept of supernode analysis? We will have discussion on that part. Coming to supernode analysis, supernode is nothing but if there is only a voltage source between any two of the main nodes or between a main node and the reference node, then the particular nodes are said to be under supernode condition. So what is the case is, if there is only a voltage source between any two main nodes, or if there is a voltage source between main node and the reference node, then the particular nodes are said to be under supernode condition. This is the main difference among the node and the supernode analysis. So let us take an example and we'll have discussion on that part, how to do the analysis of the how to find the response by using the supernode analysis. Okay, yeah. So let us consider a simple circuit. So I consider a simple circuit having of two current sources and voltage source. So this is the problem. So the given question is, find the current passing through 1 ohm resistor by using the node analysis or supernode analysis. Okay, so how to find the current passing through 1 ohms? First we have to find the node voltages. Okay, with the help of the node voltage we are going to find the response, that is the current passing through 1 ohms. So first, as the procedure is same as that of the node analysis, but the only change is we have to identify the supernode. We have to write the supernode equation as we have discussed in the previous class of mesh analysis and super mesh analysis. Here also the same, but we are going to apply Kirchhoff's current law here, and we are going to identify the supernode condition. We have to write the supernode equation, and if there is any voltage source between the two particular nodes, which is said to be in the supernode, and we are going to write the supernode equation, and next we are going to write the combined equation for that. Let us have a let us write the equations for the particular part. So first one is identify number of nodes. Number of nodes is, as we had discussed in the earlier problem, so there is I am not going to consider the branch consisting of joining of two branches as a node. I am going to consider joining of minimum only 3 branches as a node to reduce the complexity of the problem. So here 1, 2 and 3 branches are meeting at this particular node, so I will take it as a node. This is V1. Here 1, 2 and 3, this is a node. So I have 2 nodes, let V1, V2 be the node voltages. And the next step is assuming the reference node, which is very important in the case of node analysis. Assuming the reference node voltage as 0. Where I have to assume the reference node? Where all the nodes are going to meet at a common point. I can meet at this point, I can meet at this point. Okay. So assuming the reference node voltage as 0. Okay. Next we have to identify whether there is only a voltage source between any of the two nodes, whether it may be between the two main nodes or between the main node and the reference node. Here I can see that we have only a voltage source. Why I am going to consider only a voltage source? Why? Because if there is a resistor across which is contained series with the source, then it cannot be a supernode. Directly we can get the current equation for a particular part. I am going to mention clearly that only a voltage source should be there between the two nodes. That may be between the two main nodes or between the main node and the reference node. So here we can see in this particular problem, we have a 10 volt source between the nodes 1 and 2. So we can say that is the third step. 1 and 2 are in supernode condition. Supernode condition. So I have to write the supernode equation. What is supernode equation? How to write this equation? So V1, starting with the V1 minus into minus plus. So V1 is positive with respect to V2. If I start with the V1, so I am going to consider that V1 is positive with respect to the other node. So V1 minus into minus plus, whatever the value, plus 10 minus V2 equal to 0. I get the value as V1 minus V2 equal to minus 10. So here some of them might have that out. Why should I consider only from V1? I can consider from V2. Yeah, of course, we can start with the V2 also. Then we are going to get the equation as V2. So V2 is going to positive with respect to other all the nodes. So V2 minus into plus minus 10 minus V1 equal to 0. So we get the equation as if we consider if I take 10 on the other side, we get V1 minus V2 equal to minus 10. I am going to get the same equation. Okay, whether if you start with the V1 or if you start with the V2, we are going to get the same equation. This is the equation 1 from the that is supernode equation. So as we have two nodes, we have to get only two equations, right? So I have got already one equation. What about the other equation? And we have to check that if there is any node which is having no impact of the supernode. As we have only two nodes, the particular two nodes are said to be under supernodes, then there is the third node which is not having an impact of the supernode. So directly I am going to get the second equation as a combined equation for the nodes which are under supernode, that is 1 and 2. Combined equation for the nodes which are under supernode, which are 1 and 2. So we have to keep in mind that while writing the combined equation, we have to exclude the branch having the voltage source. Why? Because we have already mentioned this equation, this particular first equation. So we have to exclude the branch consisting of voltage source, which we have already mentioned. And the remaining, we have to apply KCL, apply Kirchhoff's current law, and we have to write the combined equation for 1 and 2. Starting with the first node. So here we can see that for the first node, this is one branch and this is one branch. This is the third one which should be excluded. Okay. So first we have to write the current for two of the first nodes, and we have to combine with the second node. Okay. So V1 minus 0 by 2, that is V1 by 2. Next, what is the current passing through this branch? Directly we have the current source, right? So but the direction of the current is towards the node. So we have to take it as minus. What is the value of the source? 5. So 1, 2. And this is the third one which should be neglected, the branch consisting of voltage source. So first two is completed. Come to second node. V2 minus 0 by 1, that is V2 by 1. Next, come to this branch. Here the current passing through the particular branch is 8 amperes, but the direction of the current is away from the node. So we take it as plus 8 equal to 0. You have to keep in mind that here we have a 5 ohm source, 5 ohm resistor, but what is the current passing to this entire branch is going to become 1, right? Why? Because we are going to neglect this as a node. This is entire branch is going to become, this is entire is going to become one branch. So the current passing to this particular branch is 8 amperes, but the direction of the current is away from the node. So we take it as plus. So from this we get other equation, which is second equation. On solving the equations 1 and 2, we get the values of V1 and V2. On solving equations 1 and 2, we get the values of V1 and V2. With the help of that, we can find the response in the circuit. So the question is, find the current passing through 1 ohms, nothing but V2 by, this is nothing but current passing through 1 ohm, V2 by 1. So what is the voltage current passing through 2 ohms, that is nothing but V1 by 2. That is the current passing through 2 ohms. If I want to find the power, nothing but I square into R. Once we get the current passing through this particular branch, V1 by 2, then the power is going to become I square into R. So this is the case. The other case is, if there is a voltage source only for between the main node and the reference node, then the particular nodes are said to be in the super node, and if there is no impact of the source, then directly we can apply the KCL for the remaining nodes and we can get the response. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.